In continuation with the previous three videos wherein we had discussed the module 1, module 2, module 3, now we will be discussing the module 4. And in this module 4 we have the important concept, which is the transformation from the world to viewing coordinates, differentiate between orthogonal and perspective. This is the most important one among this module. And the last one is explain the depth of our algorithm. Only 3 are important, the other ones are like rarely asked, but these 3 are the most repeated ones. Okay, so I'll be focusing more on these 3, and I'll be touching a few key concepts for the remaining ones. Okay, and if you're liking this type of videos and want more videos like this, make sure hit the like button now and subscribe to my channel for more content like this. Okay, so let's get started with the first one. Give a brief overview of 3-dimensional viewing concepts. Basically you just need to know the overview of 3D viewing concepts. So this is the overview of 3-dimensional viewing concepts. Here we have the modeling and the viewing and the projection and the clipping routines. So how does the object get viewed in the 3-dimensional and what are the concepts and the algorithms, formulas we use, as well as the functions that we'll be discussing now. Okay, so how do you view a 3-dimensional scene is, firstly you'll be setting the object here. See, these are the key points which you have to mention in the answer script if they are the 3D viewing concepts. Firstly you will place the object in the modeling frame, and then you will be using the camera to capture the image, and you will be using different perspectives. You will be changing the camera position, as well as the camera is placed under the view plane. Okay, those are the key points you have to mention. And there are two methods. One is the parallel method, other is the perspective method. In parallel method you will not have the size reduced no matter how far you go. The parallel lines will make sure that the line the object is preserving the original size. And the perspective projection, it's a more original method, because in the perspective projection, as far you go, the smaller the object becomes, so it gives a more realistic view. Okay, those are the two main algorithms discussed here, the perspective projection and the parallel projection. And those are the concepts which you have to mainly write, and along with that, if you get time and if you have like knowledge about these things, you can write this one as well. It will help you fetch more marks. Depth queuing is a method where you will be specifying the depth based on the intensity of the lines. If the line is near, you will be denoting it with more intensity. If the line is far, you will be denoting it with less intensity. Like that you can visualize if the object is near or far. Okay, next one, identifying the visible line and surfaces. We can use some techniques like making the line as dashed line, non-visible lines, or we can just remove the non-visible lines and the visible lines can be highlighted further. So those are some of the methods to identify the visible lines and surfaces. Surface rendering is the method to apply the illumination effects and the lighting effects from different perspectives, so that the object is visible. And to show if the object is smooth or rough, we will be applying some other formulas. Okay, so those are the things. Surface rendering means showing the surface how it actually is. For that, what all techniques we need, that is getting that's discussed here. Exploded and cutaway views, also we can use 3-dimensional stereoscopic viewing. So these are the subtopics which can use to fill the content. Okay, after that we have the 3-dimensional viewing pipeline. This is an important question. In 3-dimensional viewing pipeline, as I told you in the module 1 as well as in the module 2, the same thing is getting discussed here also. In 3-dimensional viewing pipeline, what you have to do is you have to transform it from the modeling coordinate to world coordinate to viewing coordinate, projection coordinate, normalized coordinate, and device coordinate. So as I have discussed in depth in the module 1 as well as 2, so I am not discussing that here. So let's move on to the next one. The next important question is explain the 3D viewing coordinate parameters. So in 3D viewing coordinate parameters, you have the x, y, and z axis, right? Because it's 3D, so you'll have x, y, and z axis. And y axis is the normal vector and z axis is the viewing vector. Okay, those are the two vectors which you have to keep in mind. View plane or the normal vector, that is the z axis. Okay, by the z axis you will be viewing the thing, so it is called as view vector. And the z vector denotes the means how far it is from the plane. So if it is near, zvp viewing projection will be greater than 0. If it is behind the plane, it will be less than 0. And view up vector is the y axis vector. So what are the key points you have to mention is that we will be using the two vectors y and z vector. That's the first point you have to use. Y vector is for the normal vector and z vector is for the viewing vector. And as the farness increases or the nearness increases, at that time the z plane will be set as follows. It will be either greater than 0, less than 0, or if it's lying on the plane, it will be equal to 0. That's the first key point. And the second key point is the view up vector is the y vector. By that we will be having the normal vector set, and this vector is used to establish the positive direction for the y view axis. After writing the theory part, you have to draw this diagram. This is the adjusted v, this is the actual v. The input will not always be perpendicular, right? so we have to adjust it, and it is not always possible to adjust it exactly. So for that we will be using a UVN, viewing coordinate reference vector, okay, because it is generally difficult to determine a direction v that is precisely perpendicular to n. Therefore we will be using the adjusted user defined orientation of vector v. For that we will be using UVN. UVN is used to adjust the vector to the perpendicular axis, okay. So the information regarding that is given, and these formulas are used to carry out the same procedure, and UVN are nothing but x, y and z axis. So by this we will be able to set that in a perpendicular axis, and we can get a better view, okay. So that's all what is mentioned in the 3D viewing coordinate parameters. Next we have to explain the transformation from world to viewing coordinates. See, world coordinates is the outer view, and viewing coordinates is the inner view, okay. This is the world coordinate, and whatever we are trying to view at the particular instance of time, that is the viewing coordinate. If we are trying to view this part, this is the viewing coordinate. How to transform the world coordinate things into the viewing coordinate things? The two steps are: translate the viewing coordinate origin to the origin of world coordinate, apply the rotation in the x, y, z axis to the xw, yw and zw axis respectively, okay. And we can use the translation matrix as follows. Also the rotation matrix can be used. This is the rotation matrix as well as the translation into rotation matrix, the combination of both. Here also we will be using the UVN because that will help us give a means better perspective of the object. And these are the equations, again the equations is the same as the matrix ones. If we expand the matrix, we will get these equations. So that was about the transformation from the world to viewing coordinate. Next is the most important question, which is the differentiate between orthogonal and perspective projection, okay. So those are the two types of projections. Here you have to pay very much attention. So two types of projections are parallel and perspective. In parallel you will preserve the size, and in perspective the size will be changing. So if we preserve the size at that time, we need not have the other equations, we can just use the same equation. This is the parallel one. The size is preserved here, just the oblique angle is getting changed. We can project it any oblique angle to the view plane, or it can be projected along the lines that are perpendicular to the view plane. This is the oblique angle because the angle is getting changed but the size remains same. But in the perspective projection, the size does not remain same because it is getting converged, and it looks like in actuality how it looks like that output is getting shown here, okay. And orthogonal projections, all the side views you have to make. This is the second thing what you have to write in the first thing is the difference between the orthogonal and perspective projection. After that you have to write this one from the different views, how it looks like, side view, front view and the plan view. After that you have to write about the axonometric and isometric orthogonal projections. Isometric means that you will have the different faces in a single sheet of plane, okay. That is known as axonometric or isometric orthogonal projections. Orthogonal projection coordinate will not change. The final coordinates will be same as the initial coordinate because the size is getting preserved, okay. That's the fourth point. And the fifth point is that the clipping window and the orthogonal projection view volume will be as follows. You have to draw a clipping window. The opposite points will denote the view plane points, and that will be given in a 3D axis, okay. So after doing this much, if you get the time and if you have the memory capacity to memorize the matrix equation, that is also helpful for you to fetch more marks. So this is the object which you have to draw for compulsory. So what is this? This is the clipping window, and this is the near plane, and this is the far plane. So if the object is present here, this is known as the far plane, which is near the original object, and the plane which is near to the clipping window is known as near plane. And the view volume is nothing but the volume formed between the far plane and the view plane. This will be rectangular parallel piped, okay, rectangular parallel piped. That also you have to mention. And yeah, basically that's it. If you get time, you can use you can do this one also. This is an extra thing, as well as the normalization functions, okay, and this one. So it's actually pretty simple to memorize this one, and they have asked explicitly regarding this one, like write the matrix values for the normalization vector for the orthogonal projection. So how do you remember these values? Is very simple. This is the x axis, y axis, z axis and nothing. X, y, z, nothing, okay, like that only you have to remember. Now this is x axis, y axis and z axis, right? So here you will write xw max, xw min, yw max, yw min. That's all. Only two things you will write: xw max, xw min, yw max, yw min, z near and z far. These three things only you have to write. Nothing else you write as of now. Since you have written xw max minus xw min, that same thing you will be writing here. This also will be writing same thing here. This also same thing you will be writing here. After I have written these four things, then you have to do the ulta of this one. Like if it is minus, do it plus, minus plus, minus plus, and add 2 minus here. That's all. Minus plus, minus plus, minus plus, add 2 minus here. Done with this one, then you have to write the same things here: xw max, xw min, yw max, yw min, z near, z far, same as what is in the denominator. Rest all fill with zeros except the last one you will fill with 1. Very easy. If you write this one, you can easily fetch 1 or 2 extra marks. Okay, and this is also very simple. Make a rectangle here, then make a square here. That's all. Don't do anything else. Okay, and let's move on to the perspective projection. Perspective projection, make sure you draw the frustum. Wherever you draw the diagram, draw the frustum. Don't draw the rectangle parallel piped. Here you should draw it like this. Okay, like becoming small, like that you have to draw. Okay, wherever you draw the projections. And the same things already discussed for the above one. Same things you have to do here also. And first point is, what is the perspective projection? The perspective projection means that the object size will not be preserved. As the distance increases, the size of the object will be decreasing, and it will merge at one point that is known as projection reference point, also known as vanishing point. Okay, vanishing point will come in the later stage. I'll tell you what to focus upon. So these are the equations, and this equation is also compulsory for you to memorize. This is known as parametric equations. In parametric equations, what you have to write is just write like this: x dash is equal to x PRP. Okay, x dash is equal to x PRP. That's all what you have to write. X dash is equal to x PRP. After that, since you are writing for x, double x minus minus, x minus x minus, y dash y PRP, then y minus y minus. That much only you write in the first step. Z dash z PRP, z minus z minus. Then put a opening bracket in between, closing bracket, and u. That's all. Opening bracket, closing bracket, and u you have to write here. Okay, that's all. So in this way you can easily write this, and you can get 1 extra mark. Okay, after I have written this one, you have to write the cases. If you can remember this, it will be helpful for you. But if you cannot, that's also fine. But this thing you have to compulsorily remember. Write it 10-20 times, but remember this one, because the cases of perspective projection, they have explicitly asked the same question. The whole answer depends on these equations. If you don't write the cases as well as the equations, you will lose all the marks. Okay. So what are the cases? There are totally 4 cases. How to remember that I will tell you now. Okay, there are totally 4 cases. Listen carefully. The first case is z is equal to 0. Just write z is equal to 0. Don't write these things. Okay, cut off these things. Just write z is equal to 0. That's all. Case 1, z is equal to 0, and inside that what you will write, xp, and just you have to remember this one, zprp minus zvp divided by zprp minus z. If you can remember this one, if you can assure me that you will remember this one, I will make sure that you will remember the remaining ones in an easy way, because if you remember this, the remembering the next ones is very simple. So make sure you remember this one. Repeat with me: zprp minus zvp divided by zprp minus z. Okay, zprp minus zvp divided by zprp minus z. Okay, if you remember this one, the 4 equations are cakewalk for you. Okay, so what you have to do is, in each of these cases you have to write the xp value and the yp value. What you have to write: xp value and the yp value. Xp value will be equal to x into zprp minus zvp divided by zprp minus z. Same thing, copy paste here. Instead of x, put y. That's all. Just remember for x, and for y you will be just changing x to y. That's the case 1. After case 1, you will move to case 2. Observe carefully what's happening. zprp will get cut off, and minus will get cut off. And what you remain? zvp by z, zvp by z. That's the answer here. zvp by z. X into zvp by z, y into zvp by z will give me xp and yp. Okay. Next, after the case 1 and case 2, you will not move to case 3, but you will move to case 4. Reason I will give you now. In the case 4, what you will do, instead of cutting off the whole thing, see, in this what we cut this whole thing, right? Instead of that, you will just cut this one. Just cut minus zvp. Just cut minus zvp. What you remain with? zprp by zprp minus z. That's the same thing we will write in the case 4. zprp by zprp minus z, zprp by zprp minus z. X and y, xp and yp. Okay, don't worry about this. I'll tell you what to write here, but for now just focus on the equation. And quickly rewrapping what I told. Here you will remember z prp minus zvp divided by zprp minus z, and that you will multiply by x to get xp, multiply by y to get yp. After that you will move to case 2. You will cut off this part. Okay, when you cut off sorry, not this part, zprp minus minus, zprp minus minus will be remaining with zvp by z, zvp by z. That's the case 2. Multiply by x to get xp, multiply by y to get yp. After that, we will move to case 4. There we will cut off the zvp minus zvp. So whatever remain, multiply by x to get the xp value, multiply by y to get the yp value. Now we will move on to the case 3. In case 3, again refer the same equation here. In this equation, basically what you will be doing is, you will be splitting the numerator. Splitting the numerator means this term will be taken separate and this term will be taken separate. So basically what you will have, zprp by zprp minus z minus zvp by zprp minus z. Like this you will have. All you have to do is put x here, the same thing, and put x here also, just write PRP and cut VP here. Okay, VP you have to cut here, that's all. X PRP will be here, just Z, Z PRP minus Z, here also Z PRP minus Z, Z PRP and X. Same thing goes for Y as well. So if you observe carefully in the case 3, that's the same thing which I have told. Z PRP by Z PRP minus Z into X, Z by Z PRP minus Z into X PRP. Just change X into Y, you will get the Y also. Just focus on X, that's all. Y you'll just have to change the letter only, right? Nothing else. So these are the 4 cases, very important. Make sure you never miss this one before your exam. Okay. And moving on, we have the frustum diagram. So if you can write these things, okay, write these things are nothing but see here, the object is here, it gets focused at this one, and if you again increase, it will become inverse of it. Like in the 12th standard and 8th standard, we studied in the light chapter, right? If the object is like this, it comes and converges here in the focus point. Again you go like this, this will become a reverse of it, right? That's the same thing I have to mention here, and the same thing will happen in the perspective projection as well. And as you increase the length, you will be getting the parallel projection, you will be approaching towards the parallel projection. This is another key point. And another key point what you can write is about the vanishing points. Same thing, vanishing points, as I told you, what is the projection reference coordinate, that's the vanishing point itself. Okay, if you can make this diagram and write in the opposite axis also, that's also that can also help you to fetch more marks. And you have to make this diagram for sure, like how you had made for rectangular parallelepiped. Here you will have rectangular frustum view volume. So a bigger plane here, as it moves towards the vanishing point, it will become smaller plane. This is the clipping window. Okay, now we can have 2 types of frustum. Just remember this one type of frustum, this is another type of frustum. This is straight frustum, this is the tilted frustum. Okay, so there are many transformation matrix values also. Actually it's very hard to memorize that one, so that's why I'm telling you remember the other key points so that you can fill the content. Okay, so these are the matrix key values. If you can remember, it is good for you, but if you can't remember, at least draw this diagram. This is the symmetric one and this is the oblique one. Okay, draw these two, one is the straight one, other is the tilted one. Okay, so I guess this much content should be sufficient for you to fetch at least maximum marks, not if the full marks, because full marks you will get only when you write these things. Okay, actually it's very hard, even I am not able to memorize these matrix values here. So it's okay, whatever the content you can write, just write, and let's see what will happen. Okay, and as I told you, for the parallel projection, you have the normalization values also. Draw cuboid here, and sorry, the rectangular parallelepiped, and draw cuboid here, and write any matrix value here. Okay, write anything in between. So this also matrix value. See, as I told you, there are many matrix values, it's hard to remember, but at least for the parallel one you remember. Okay, I told you that trick, right? So for that you remember, and yeah, that's all what is there, the content in this question, orthogonal and perspective projection. Very important question from exam point of view. Then we have explained the various visible surface detection methods. So what are the various visible surface detection methods? It's in page number 35. So after this, the questions are not that important, just for your information, and if they ask, you can write that one. But last question is there, depth buffer method. That's an important question. Okay, so here there are 2 methods, object space method and image space method. For any question, just remember one key point. Okay, don't try to remember everything, time is limited. So what you need to remember in object space method is that you will detect the object, that's all, nothing else. Image space method, you will detect each pixel, that's all, nothing else. Okay, by that only you have to expand it. Okay, then you have backface detection method. In backface detection method, in module 3 also we saw, this is the equation. If it is less than 0, it is behind the plane. If it is greater than 0, it's in front of the plane. If it is equal to 0, it's on the plane. Okay, so same thing can be applied in the objects present here also. And depth buffer method, this is an important one. Okay, so let's see what is the other questions in between. Explain the 3D OpenGL viewing functions, visibility detection functions, differentiate between parallel and perspective projection. Parallel and perspective projection is in last page, I'll discuss it last. Before that, let's see the other 3D viewing functions. So these are the different depth buffer and visibility detection functions. So I'll scroll slowly, you can get the important ones, I'll tell which are important. GL enable, GL cull face, and GL init display, GL clear, and GL enable and disable. This for what we are using is, if you don't use this one, we will not be able to see the depth perspectives. Okay, so we'll be using enable or disable the GL depth test. Also we'll be using the clear depth, depth range, depth function. These are for visualizing the depth. Okay, and wireframe methods for the polygon and enable and disable, and this is the perspective and parallel projection. So here's some information, you can go through it. The same thing what I discussed for the orthogonal as well as for the perspective just now, that's summarized here. Okay, so this can also be used in the previous answer. And what is left? Okay, these are the OpenGL functions, GL matrix mode, GL ortho, GL frustum viewport. Anyways, yeah, you had learned for the lab, right? Reshape function and all. So the same thing, yeah, I have to write here as well. Okay, so let's move on to the last topic, which is the most important one, depth buffer algorithm. So you have to write a theory regarding that. What is depth buffer algorithm? Let me tell you what is depth buffer algorithm. See, as you have object in front of you, like you have iPhone 6 in front of you. Okay, now you have thrown that iPhone 6 in front of the building. You are standing at a 16th floor building. You throw your phone. Okay, now as your phone goes down like that, your phone will become small like that, right? So that will denote how much deep it is. The more small it is, the more deep it is. Okay, so in the same way, to visualize the depth, we'll be using the depth buffer algorithm. In depth buffer algorithm, the various views of the scenes will be captured at different intervals of time, and it will be seen that how much visible it is. Like if it is rarely visible, it is more depth. If it is highly visible, it is very near to you. Okay, so that's how we'll be using the depth buffer algorithm, and here we'll be using Z buffer method. Actually, you need to go through the content at least once to get to know what actually you have to write. Okay, this is just the explanation. Okay, so for that we'll be using the Z buffer algorithm. A few points you have to keep in mind. The first point is that you'll be using two buffers. How many buffers you'll be using in depth buffer algorithm? Two buffers. The first buffer is the depth buffer and second is the frame buffer. In depth buffer you'll be initializing the depth value, and in the frame buffer you'll be initializing the color of the frame. So background color will be initial color. Now as the color changes, it will take the color for the surface color. Okay, and the depth buffer will be the Z value. How to calculate Z? Z is again calculated by the same equation, ax plus by plus cz is equal to d. If you forget, you can derive by using this. What is Z value? Z will be equal to minus ax minus by minus d by c. That's the third point. And the next Z value will be just x plus 1. Actually increment by 1, so it will be x plus 1. If you subtract both of these equation, you will get Z minus a by c. So a by c is the factor by which the Z gets depth gets changed. Okay, so if you are presented here, and how do you move here? This difference is nothing but a by c. If you subtract a by c from this one, you will get z dash. Z minus a by c is equal to z dash. That's the same equation which is given here. That's the fourth one what you have to write. And the fifth point is it is same as the scanline algorithm. Here we will be using x minus 1 by m. There you will be using x minus 1 by m to get the next x value. Here we will be using z minus a by c to get the next z value. So the same algorithm can be applied for the 3D objects also, the scanline algorithm, and the functions are given here. What are the functions I told you? That's important ones, and these are the extra ones. If you can remember, you can remember and write. Okay, make sure not miss the 3 important questions I told you. Just for your reference, I again repeat what are the 3 important questions. The first one is the world to viewing coordinates, orthogonal and perspective projection, and the depth buffer algorithm. So make sure you hit the like button and subscribe to my channel, and I'll see you in the next one. Thank you so much for watching.